Now I am going to explain function generators. At the end of the session, you will be able to know what is a function generator and their applications and understand the operation of a function generators. What is a function generator? A function generator is a signal source that has a capability to produce different types of waveforms. These are the different types of waveforms that will be produced by a function generator. That different types of waveforms are sine wave, square wave, triangular wave, as well as a sawtooth wave. Right. So the frequency of these waveforms from a fraction of hertz to the several kilohertz. The function generator will be produced 0.01 hertz to the 100 kilohertz of frequency of that signal. Function generators are versatile instruments as each waveform they generate a suitable for different group of applications. Right. This is the block diagram of function generator, which is having different blocks. This is the frequency control network which will produce in the oscillations. This is the constant current supply source 1. This is the constant current supply source 2, and integrated circuit and voltage comparator multivibrator, which will switch the circuit, switch the integrator and switch the current sources to the output. That will be if the current sources, the current is greater than predefined value, that will be connected to the output amplifier 1. It will produce the square wave. And if the integrator, the output of the integrator is directly connected, we will getting the triangular wave. If the comparator value is decreased to predefined value, that will the current source, the integrator is connected to the current constant current supply 2, then we will get the sine wave. Right. With the help of the resistance diode shaping circuit, we will getting the sine wave. We will discuss in brief of all these blocks one by one. Right. The block diagram of function generator, which will be having frequency control. That is the frequency control means this one. This will be calling as a frequency control. The frequency control is used to regulate two current sources. That is the control the frequency, and the upper current source supplies constant current to the integrator. That is the current source 1 supplies the constant current source to the integrator, produces an output voltage that is increasing linearly with time. Lower current source which supplies a reverse current to the integrator. It means that will be minimum predefined value, so that its output decreases linearly with time. The integrator output voltage is given by V0 is equals to 1 by C. This is the value of the capacitor. 0 to T. This is the current flow through that one into dt. The frequency is controlled by varying the upper and the lower currents, and an increasing or decreasing in the current will increase or decreases the slope of the output voltage and controls the frequency. The voltage comparator is used to changes the states at a predetermined maximum and minimum values of the integrator output voltage. When the predetermined level is reached, it changes the state and switches the current source. It produces a square wave. Right. When the predefined value will be, the current will be maximum, that will increase the predefined value, that will be connected to the upper current source. If that will be goes to minimum, that will be connected to the lower current sources. The integrator output is a triangular waveform whose frequency is determined by the magnitude of the constant current sources. The comparator output delivers a square wave of the same frequency. The resistance diode network produces a sine wave from the triangular wave with less than 1 distortion, 1% of distortion. These are the specifications of the function generator. It produces a sine wave, square wave, triangular wave, as well as a sawtooth wave, and it can generate a wide range of frequencies which covers edge to the, that is the minimum frequency to the 100 kilohertz. The frequency stability is 0.1% per hour for analog generators or 500 percentage per minute per digital generator. The maximum sine wave distortion of the output is 1%. Some function generators can be phase locked to external signal source, which may be frequency reference or another function generator. Okay. The amplitude modulation or frequency modulation or phase modulation may be supported for the phase locking. The output amplitude is up to 10 volt peak to peak, and the amplitude can be modified usually by calibrated attenuator with decade steps and continuous adjustments within each decade. Some generators provide DC offset voltage, example adjustable between -5 volts to the +5 volts, and output impedance of 50 ohms. This is the front panel of a function generator. This front panel of a function generator will having various knobs, and these are the various knobs, nearly 20 knobs it will be containing, and one display. Okay. This is the digital function generator, which will gives the output the values of the voltage and frequency also will be displayed, as well as a waveform is also displayed. These are the controllers. The first control is the power switch. This one is the power switch, which will be used to on the power and off the power. The second one is a setting adjustment knob. It is used to adjust the parameters selected by the other buttons also. And the third one is sine wave selection. By pressing the sine wave selection button, we will get the sine wave output. The fourth one is counter or trigger input. Means the input terminal of a frequency counting or external trigger signal. Note there is a maximum signal input rating. The fifth one is ramp wave selection. By pressing the ramp wave fifth button, we will get the ramp wave at the output. The sixth one is modulating signal input. This modulating signal input. The modulation may be in the form of AM, FM, or phase modulation also. The seventh one is square wave selection. By pressing the, when we press the signal, we will getting the square wave on the display. The eighth one is synchronization signal output. It provides a signal that is in phase with the output signal. Often we are using transistor logic levels. The ninth one is amplitude offset volt adjustments. This knob is used to adjust either the signal amplitude or DC offset voltage. The fourth one, the 10th one is the signal output. We are connecting the probe to this, connecting probe this pin, we will getting the output. This output is connected to the CRO. That CRO will produce the which type of signal we are connecting. That will be sine wave, square wave, or triangular wave or square wave. That will be displayed on the screen of the CRO also. You have the 11th one is the set to continuous mode. This is enables the counter input and displays the frequency of the input signal on item 4. Right? It will display the, when we press the 11th button, we will getting the frequency value. Change the utility of the setting. It is used to adjust the sweep start frequency, sweep stop frequency, and display intensity. The 13th one is the set DC offset. It enables the adjustment of the DC voltage added to the signal output. And the 14th one is the selection modulation. It selects the different types of modulations. This one, different types of modulations, that may be AM or FM or phase modulation also. The 15th one is the duty cycle. It adjusts the delay cycle or symmetry of the display waveforms. And the 16th one is the sweep. It turns the frequency sweep mode on and off, and allows selection or linear sweep or logarithmic sweep. The 17th one is the frequency. After pressing this button, the adjustment knob, that will be the controller 2, will adjust the output of the signal frequency also. That the 18th one will be the mode switch. After pressing selecting the type of operation, continuous output or trigger repetition rate or trigger, each trigger signal causes the generator to output one period. Externally trigger manual trigger pressing the button causes one cycle to be output. External gated, that means waveform cycles are output while the gate signal is above the threshold level. The 19th one is the digit adjustment. Move the digit selection left, this one. By using the 19th button, we can move the digit button to the right by using a 19th one and left to the 20th one. The 21st one will be the display. These are the specifications of a function. That is the front panel blocks functioning of a function generator. The applications of the function generator is used as a clock source, used in the development, test and repair of electronic equipment, and testing audio DAC, that is the digital analog converters, and DC power supply test, testing medical ultrasound equipment testing, next generation of a signal generation, AM or FM radio test, and alignment. These are the some of the glossaries. Integrator, an element whose output signal is the time integrated of its input signal, is calling as a integrator, which will produce in the triangular waveform. An amplifier, an electronic device that increases in the voltage or current or power signal. The next topic is random noise generators, arbitrary waveform generators. These are the simple short answer questions. What is the function generator? What are the applications of function generator? The sample long answer question is explain the operation of function generator with a neat block diagram. Thank you.